Hello all, we are here for the lesson number 29 of this VariCAD training course, and this lesson is called Shape Representation of 3D Objects. In this lesson we are going to see about the several ways we have to represent 3D objects. To show you the main functions, I will call a file I have prepared. This file menu, command open, and I will import a step file with this name here, open. Okay, this is a standard mechanical part. It doesn't matter the purpose, just to see the functionality inside the program. So this is a basic solid. Okay, we can see this in several ways, but one of the things we can see, and it is one of the specifications, if you can call it correctly, of a solid, it is a closed volume, so we can use these kinds of functions, the blendings and Boolean operations. As you can see, if I try to make a blending, a fillet in this case, no problem. Or if I try to calculate the volume, for example, object information, okay, which is a solid, and I can, for example, solid calculations, volume, mass, center of gravity, moment of inertia, so volume. For this object, being a solid, being a closed object, it can be calculated volume, center of gravities, and by all means mass if you define the density. So this is one of the purposes to have a solid. Okay. Step is a very nice format to change information from one system to another. This protocol at this moment is the most widely used to change information, to read and write information from one system to another globally. But sometimes it may happen some problems on the process, either on writing the file or reading the file. Okay, so inside VariCAD, what it happens is when we create new solids, it's not very common to have problems. So I can create in this case, a very simple solid. Okay, this is a big one. I can create a very simple solid, and for sure it will be closed. It will have all the properties that we know for solids. Okay, I can create this one. It was very big, but just to show you what you already know. But sometimes when we try to make some operations, we can have some mistakes. It's not common, but it can happen. The other thing that it might happen is when we try to import step files coming from other systems. In this case, it's more frequently to have problems because each system has its own variables, has its own way and configurations to write the step files, and when someone or some other program, in this case we are talking about VariCAD, but it can be other software, when we try to read that file, we may have some problems. And the first consequence of this is that what we want to obtain, like this one, that is a perfectly closed object, it can come open. Okay, so I will show you. In this case we import a perfectly closed object, but I will try to show you what it may happen if when we import a step file we have some kind of problems with the surfaces, with the patches of this object. So we have some functions that intend to analyze the objects, and for that we may need to come to this objects menu and coming to these open solid features. So the first thing is to analyze what we have. So we may come here and say display all open solids. In this case we have only one solid inside. We may have an assembly, and this will analyze all the solids inside the file. So all open solids, in this case no problem, so no open solids are detected in space. For the same reasons, if we come to this function below, which is what we can call a sub-function of the first one, if we detected an open solid, then we would like to know where it was open on that solid. Okay, so we don't have any problems, but we will create some problems in this object. So this is to tell you that the first thing, the first state, the first representation we have inside VariCAD is a solid, a closed object. Okay, and this has all the properties and can run all the commands we have inside the program. But we can have a kind of a lower degree on this. Okay, and I will delete one of the patches, one of the surfaces, and say convert a solid to object with missing patches. Okay, so I will delete this face here, and as you can see, now I have a solid where you can see the inside of the solid. Okay, it has this very black color. It's a characteristic of the second state of objects, which we call solids with missing patches. We don't have many tools to close this, so we cannot close it. And even that we have this, what we can call hybrid states. It's not a closed object, it's not a object that we cannot work with, but it's always best to have the closed solid. These are states that if you cannot get anything better, then we are going to try to live with this one. So, but in this case, for example, even that is open, I can do these kind of things. Okay, you can see that is open, or we can do, I will do the undo, or we can do things like, for example, there's insert a solid, smaller one, so kind of this, some kind of this. So okay, and now to make a Boolean operation, okay, you can see that is open, but we can work with this open solid almost with all the functions. Okay, we would get problems if we try to make things where it is open. As you can see, it does not let me choose, but the true limitation is where it's open we cannot work, but on the rest of the solid we may get all the functionalities. So this is the second state. We have a lower state that is called open shell. Okay, and if we come here, objects, and say convert a solid to an open shell, then okay, I will, to be faster, I will delete this surface here and say okay, and now you see that I have it's similar in terms of display, but it changed the color. Now it is something that it cannot support any volume operations. We can turn back and convert this to the second state, which is the solid with missing patches. But in this case here, we cannot do, okay, if you try, we cannot do any kind of these things. But sometimes when we import things, we get this kind of result. Working with VariCAD and coming from a closed solid to this kind of representation, I don't see any advantage. Even that VariCAD says that some systems like to work with the objects like these ones. At this moment, almost everybody work with solids, so I don't see much of an advantage to come to a higher state to this lower state. Okay, but reaching this state, if for some reason when we import a part we get this, we can go to the missing patches object, and again we can come here and go to the convert a solid to object with missing patches. So I will, to be faster with choosing the, I will say this, and okay, again I return to the previous state, and to show you that I've returned with this, okay, he accepts again. It's an open solid with missing patches. I can try to show you also the volume mass. It cannot perform because it is open. Okay, just to confirm you that it supports almost all operations, but these kind of things, it is not possible. So these are the three states. So closed solid, solid with missing patches, like this state that is shown now, and the open shells. Okay, there is a lower state. I don't see any advantage, so I will not show you in particular, because, and it is called solid to a set of patches. This state has no functionalities available. It does not allow to come to these higher representations like these missing patches, so I don't see any big advantage on working with these guys here. Okay, I need to show you still these functionalities, which are the all open solids. Okay, here it is shown where it is open, even that we don't have any functions. This is the open solid if it was an assembly. We don't have any tools to repair these, but at least we can know where are the problems, and we may try, if it is an assembly, try to get a better file when we write this particular part on another system. Okay, so in these open solid features, we've seen all the three states, or at least the two important ones. I'm leaving these behind because I don't see much of advantage. We have this display open solids on an assembly, and where inside the solid, where are the holes. Okay, besides this, we have some what they call reparation tools. Okay, I will show you these three last options below, and the first one, it is converts to imported object destroy creation history. If we make a solid, okay, can be anything. I will use the cube again. You see that this solid has some history, and even that we did not see this, we are going to see these commands on the next lessons. Having some history on a solid, some tree of things, allow us, for example, to come and edit this solid. And the addition is something that allows you to, somewhere on the middle of the events that where you work with this, you can, for example, edit a dimension and rebuild this automatically. Okay, this is the history of the solid. If somewhere we do this command, converts to imported object and destroy history, then okay, you have the same solid. You can work still with the Boolean operations and so on, no problem. But if you try to make the edition of the solid, it is not possible because it does not know it destroy all of that information. In this case, I could work on the blending, but because the blending was done after the delete of the history, and in this case I could edit and say rebuild just that part, okay, but the dimension of the solid, it is lost. The other things we have below is something that it is called reverse all normals, reverse normals at selected patches. It is not very common also to get problems when we import a closed solid. One of the characteristics and that make us a good result on the import is that if the solid it is perfectly closed without problems, all the normals are oriented to the same side. So you can see that this color inside everything is black, outside everything is gray. So the normals are correct. Okay. If we try to import it again, so I may do this. If we do this reverse all normals, you will see that the black will be for the outside and the gray inside. Even on this, it should have no big issues, but it may happen that there are some problems with this reverse of the normals. Let's try to do this. Okay, you see that here, for example, when we revert the normals, we are already getting problems because mathematically it's having some kind of issue here. I don't know why, but it's having some issues. Okay, we may get these kind of problems when we import the file. Okay, so for example, let us do this again and revert all normals. Okay, and in this particular case I would like to go to the last function and says instead of reverting everything, just revert some. So okay, I'm reverting all with that exception. So let us try to do now, because there was a mathematical issue. So now it has problems because some normals are outside, some normals are inside, so it cannot make the calculation. So this is to end this lesson, just to make a little resume of what we talk. So we have several degrees on the representation of the 3D objects, so it's always best, always, and we should make all the efforts to have always closed solids without problems, clean. If it is not possible, we may have to work with these solids with missing patches. Okay, has some limitations like we've seen, like the volume, like the Boolean operations or blendings or wherever it is open. And we have a lower state, the open shells, that does not allow us to work with the blendings, with the Boolean operations, but at least has the advantage that it may allow us to go up to the higher state of the missing patches. Okay. Besides that, we have this reverse normal stuff, all the model or only some of the patches. To be very honest, I don't see much of use of this in today's solids, but you may get some problems once in a while if it is common for you to import parts from customers or from other databases of parts. So this is something that may allow you to solve some problems when you get this kind of issue. So with this, I finish this lesson, and I hope to see you on the next one.